Hey guys, lesson 4.2, horizontal and vertical lines. So we are talking about horizontal and vertical lines on the coordinate graph. Learning target today we should be able to identify if an equation has a vertical or horizontal line and graph the line. We should also be able to give the equation for a vertical or horizontal line. And as a review in this lesson, we are also going to be taking a look at graphing any line that represents an equation with an x and y variable. That line may be vertical, horizontal, or oblique, which is our mathematical terminology for a diagonal line. Taking a look here at our warm-up, I am going to ask you to give 3 xy pairs that satisfy the given equation or rule. So go ahead, press pause for a moment and find 3 xy pairs that satisfy the given rule or equation. In the first one, here are a couple possibilities: 0, -5, 1, -1, -1, 9, 4, 9, 2, and 3. Why are these possibilities? Because the first number in our pair represents x, the second number represents y. So if I take a look, I can see that my y value, -5, is equal to 4 times my x value, which is a 0, minus 5. Upon evaluation, using order of operations, we would see 0 minus 5, which is a -5. So taking a look, the way that I ended up finding these values was by picking the x. Like, I just decided what the x value was going to be, and I substituted it in to find out what y was. This made sense to me because the equation is written for y in terms of x. I know it's written for y because it says y equals in terms of x, meaning if I know x, I know y pretty quickly after that. Some possibilities for the second equation are 0, 15. In this case, I picked an x for 0 because if x was a 0, then very quickly I knew that this whole term was a 0, and so y must have been equal to 15. If we take a look here, I wanted to find another point on this line, and I got a point of 5, 0. In this case, I picked 0 for y because if I knew that this y was a 0, that would make the whole term 0, and 3 times something equals 15. 2 and 9. In this case, I picked x equals 2. The reason why I picked out the x was because the y was all alone. It seemed like it would be easier to find. As soon as I knew that x was 2, this whole term was a 6, and 6 plus 9 equals 15. The reason why we're starting with this warm-up is because that reminds us of graphing. In our warm-up, we had at least 3 pairs of value that satisfied the equation, so it should be easy to graph the line as long as they line up. So we start with a graph. We have to draw an x and y axis in. Typically, unless for some reason we know negatives shouldn't be included, we do include all 4 quadrants of the graph. We pick a scale for each axis. Here you can see I chose a scale of 1 for the x-axis and a scale of 2 for the y-axis. I plot the points that I found, so we will see the points showing up. 0, -5, 1, -1, -1, -9, 4, 9, and finally 2, 3. We see the points showing up, and if I place my straight edge on the graph, I will see that they do in fact all line up perfectly. And now I have just graphed the line for the equation y equals 4x minus 5. We can graph the equation for the second line for the equation in the second part of our warm-up. 3x plus y equals 15, again using the 3 points that we've already found. I'm going to draw my x and y axis, pick a scale. I'm just going to go with the same scale of 2 on the x-axis, a scale of 1 on the x-axis. Each space represents 1, 1, 2, 3, 4, and a scale of 2 on the y-axis, 2, 4, 6, 8. Graph the points that we found: 0, 15, 5, 0, and 2, 9. And sure enough, if I place my straight edge, it does in fact make a wonderfully straight line that represents the equation 3x plus y equals 15. Every ordered pair on that line fits, it satisfies this equation. Every xy pair fits in the equation 3x plus y equals 15. Now, this lesson is specifically about horizontal and vertical lines. So let's do some horizontal line investigation. Let's just begin by drawing a horizontal line on the graph. There's a horizontal line on the graph. Let's identify a couple of ordered pairs on this line. So here's one, negative 6, 8, 0, 8, 6, 8, negative 3, 8. So we've just got a couple different lines, or excuse me, points on the graph. If I take a look at each of these points on the graph, I can see that there is actually a rule for x and y here. The rule that relates x and y in this case is that x can be anything. No matter what x is, my y is always the same. No matter what x I pick, no matter how far left or how far right, y is always going to be the same. The y will always be an 8 because it's a perfectly horizontal line. So the equation for the line is y equals 8. We really don't need anything to describe the x value since it can be anything. So again, the equation for the line in this case is simply y equals 8. The equation format of a horizontal line, every horizontal line has an equation of the form y equals k, where k is a real number. So again, every horizontal line has an equation of the form y equals k, where k is a real number. Let's talk vertical lines. So again, we're just going to go ahead and draw a vertical line right on our graph. Find a couple ordered pairs for some of the points in the graph. So here's one. This actually should say negative 3, negative 4, if we want to fix that. Negative 3, negative 4. So if we take a look here, taking a look at this particular rule for x and y, no matter how high the x is, no matter how high the y is, or how low the y is, the x is always going to remain the same because it's on a perfectly vertical line. So the equation for this particular line is x equals negative 3. We don't need to describe the y value since it really can be anything. The equation for a vertical line always takes the form x equals h, where h is a real number. As we take a look, I would like for you to give an equation describing all the points on the line graphed below. It may help to make a few sample points, a few sample ordered pairs to find the relationship between x and y. In this case, we know that y equals negative 3 because no matter what the x value is, we always have the y value being negative 3. There's a similar example on page 189 of your textbook. Another example, I'm going to ask you to graph x equals negative 15 first on a number line and then on the coordinate plane. On a number line, it only considers one variable, in this case the x variable, so we just want to locate the place where x equals negative 15. On a coordinate graph, we need to consider all pairs of numbers, x and y, where x equals negative 15. In this case, the y could be anything as long as our x value stays right here at negative 15. A similar example can be found on page 189 and actually page 190 of your textbook. Finally, horizontal and vertical lines on a graph can help us answer some questions. For example, if we know that Ricky is taking $1,400 with him to college for spending money, he spends $100 per week, how many weeks will his money last? We can make a graph showing the amount of money that Ricky has. Graph the first couple weeks. So you can see a graph here. We've got weeks down here on the x-axis, and we've got the spending money that he has. At 0 weeks, he still has $1,400. After 1 week, he's down to $1,300. 2 weeks, he's down to $1,200. We see the general pattern here, so we can graph the line. At this point, we would want to locate the trend line and find out when he is here at $0. So we have a vertical line at $0, and we can see that that happens at 14 weeks. You'll find a similar example on page 190 of your textbook.